Hello, my name is Ruth Steiner of the University of Florida. I'm here to discuss the transit accessibility tool that I developed with my students with the assistance of my colleague Ilir Baileri for STRIDE Project C3, Emerging Mobility Services for the Transportation Disadvantaged. This tool is a modification of a tool that Dr. Baileri and his students developed to understand the transportation service gaps for the transportation disadvantaged populations. The big picture is that transit agencies have equity goals that need to be met. Agencies can be made aware of places where equity goals can be served best using basic GIS tools. One of the first steps in achieving these goals is understanding what places qualifies best for changes in service frequency, new routes, or other transit services. The map on the slide shows the first step in looking to areas that may have high levels of populations that are likely to be transit dependent. Transit agencies and planners may have a challenging time simultaneously designing a system that works for different groups of users, commuters, students, people attending special events, and multipurpose users, and for transportation disadvantaged populations such as older adults, persons with cognitive and physical limitations, and low-income populations. Understanding how well served a community is involved understanding the dynamics of various trip purposes such as work, school, shopping, healthcare-related activities, and recreation. Some GIS tools do not provide a robust enough outcome to address these equity concerns. And few tools help to align transit agency goals across multiple different trip purposes. Thus, there is a need to develop a tool that provides an understanding of the context of an area that may experience gap in transportation service and implement strategies and forecast their impacts may help to add another layer of understanding of the equity issue. The transit accessibility tool is a GIS tool that can help to understand the transit network using a transit travel time cost algorithm. If a trip is feasible within 90 minutes, the trip is considered to be possible. The tool considers destinations of 5 trip types: work, medical, education, social and recreational, and grocery shopping. It allows planners and modelers to understand in great detail if certain communities are able to access multiple destination points or just a few of each of these types of destinations. This is a robust outcome since it can help to dispel the blanket statement that if there is transit, a feasible mobility alternative exists for users. This analysis identifies places for which this may not be entirely true, places that might be called transit deserts. It can also detect places with good and very strong and robust transit service. Additionally, the tool can be used to model operational changes and their potential outcomes. In order to generate these robust results, someone familiar with GIS uses numerous data sets, including population and demographic characteristics, such as age, income, automobile ownership, parcel data, employment data, transit routes, and the locations of points of interest for the various destinations, employment, medical, educational facilities, social and recreational, and grocery stores. The data sets then connect residential parcels to these various trip purposes. The data may need to be pre-processed to achieve desired outcomes. This is especially true when using transit data sets like the General Transit Feed Specification, or GTFS, which may require would be used to show the time of arrival at different bus stops. This tool helps to provide an estimated measure that helps to understand the modeled behavior of any changes in transit, adding a new route, changing an existing route, or representation of ongoing conditions. For example, the impact of COVID-19 on transit accessibility. Transit change benefits may be hard to measure in real scenarios because some of these may require that actual buses and time schedule changes be in real time. This would mean that various scenarios could be developed to see which provides the best outcome. The scenario map can demonstrate the improvements of transit on a base scenario and help to identify small areas where transit changes would make the greatest impact. The best impact scenarios are good for agencies to discuss new routes, better service frequency, and other such improvements that would provide improve the overall transit goals. Changes in routes, the new routes, and the populations to plan for can be developed more quickly and adequately with this tool than when using other tools. If you are interested in knowing more about the transit accessibility tool, do not hesitate to contact me at rsteiner@ufl.edu.